Welcome to the 7th episode of the Grand Cosmic Story. What is light? Is it just the absence of darkness? When did the first light come into existence? Is it the first thing that happened in our baby universe?
Are you curious about the world around you? Do you wonder what else is out there beyond our world? Dr. Latha Christie, a scientist and an author, will take you on a journey through the universe. Join her in exploring the universe through her web series, The Grand Cosmic Story. Stay tuned to find out what today's episode is all about.
We all love bright and sunny days, and we take it for granted that our universe is filled with objects that give us light. However, astronomers say that the early universe was not this way. It was very dark. There was no trace of any light. It was filled with the hot soup of particles, protons, neutrons, and electrons in the form of ionized plasma. As the universe started expanding and cooling a bit, the protons and neutrons began combining into ionized atoms of hydrogen and eventually some helium. But the universe was as hot and dense as the core of a star like our sun, and it had the temperature and pressure to actually fuse hydrogen into helium and other heavier elements. This fusion process generated photons of gamma radiation, but these primordial photons were trapped and could go nowhere. Everywhere it was more hot and dense. That was the reason for our dark universe. But after around 380,000 years, these ionized atoms of hydrogen and helium attracted electrons, turning them into neutral atoms, which allowed the photons to freely travel throughout the universe, the first time making the universe bright. But after that first blast of light, everything was dark. There was no stars, no galaxies, just enormous amount of these primordial elements. For the next 850 million years or so, these elements came together into monster stars of pure hydrogen and helium. These stars were huge, hundreds of times the mass of our sun. These are the population tree stars, or the first stars, and we don't have telescopes powerful enough to see them yet. Astronomers indirectly estimate that these first stars formed around 650 million years after the Big Bang. Then those first stars exploded as supernovae, more massive stars formed, and they detonated as well. That process was so violent, and I wonder what that would have looked like with stars going off like fireworks lighting up the whole universe. The emergence of these first stars marked the end of the Dark Ages in cosmic history, and this era is called the era of reionization. The most important thing that happened in the baby universe is the emergence of light, reminding us of the famous verse, "Let there be light." But how did we find out about the history of our universe? Astronomers are in some ways similar to archaeologists. To discover ancient cities, archaeologists dig vertically deep down into the ground, and the deeper they dig, the more ancient cities they uncover. Astronomers look deep into the space using space telescope operating at multiple frequency bands, especially infrared, and hunt for the trails of the earliest stars and galaxies. The speed of light is an amazing tool for the study. Since light only travels a mere 300,000 kilometers per second, when we see distant objects, we are looking them back in time. Imagine light leaving the nearest star, Proxima Centauri, and traveling through space and time to reach us. We are essentially seeing it as it was when light left the star 4 years ago. When you see the moon now, you are seeing the light that started a little more than a second ago from the moon. You are seeing it as it existed about 1.3 seconds back. You're not seeing the sun as it is today. You're seeing an 8-minute-old sun. In the same way, you will be seeing a 50-minute-old Jupiter, a 4-hour-old Pluto, and so on. To study distant objects, astronomers need powerful infrared telescope. This is because by the time the light from far off objects reaches us, the color or wavelength would have been shifted towards the red end, something we call it as redshift. Einstein's general relativity tells us that as the universe expands, the space between objects stretches, causing objects or galaxies to move away from each other. Hence, any light in that space will also stretch, shifting that light's wavelength to longer wavelengths. Redshift means the light that is emitted by distant stars and galaxies as visible or ultraviolet light actually gets shifted to redder wavelengths by the time we see it here and now. The farthest objects from us exhibit very high redshifts. Visible light is generally shifted into the near and mid-infrared parts of the electromagnetic spectrum. That is the very reason we can see the first stars and galaxies with the powerful near and mid-infrared telescopes. Now, can you tell me how far we can go back in time? We can go back as far as 13.7 billion years, almost as far as 380,000 years after the start of the universe, when the first light started traveling through the universe. If you run the clock of the universe backward, closer to the beginning, you get to a place the earliest possible light that astronomers can see. That is called the cosmic microwave background radiation. Because the universe has been expanding over the 13.7 billion years from then until now, these earliest photons were stretched out or redshifted from ultraviolet or visible light into the microwave end of the spectrum. The universe is celebrating its existence. The existence of this cosmic microwave background radiation was found by two researchers accidentally. On May 20th, 1964, Arno Penzias and Robert Wilson from AT&T Bell Laboratories, New Jersey, were working with their sensitive horn antenna. Their device picked up an old buzzing sound, persistent background radiation coming from all directions of the sky. The noise frustrated Wilson and Penzias, who thought that their instrument was apparently malfunctioning and did their best to eliminate all possible sources of interference, even removing some pigeons that were nesting in their antenna. They were perplexed as they were not able to eliminate this part of the signal, and this was present day and night throughout the year. After eliminating every possible explanation, they finally realized that they had accidentally stumbled upon something big. They had spotted the cosmic microwave background radiation, the first light of the universe. We cannot see this light because it is in the microwave part of the energy spectrum. Astronomers were so fascinated as they felt that they had reached out to the treasure of secrets about the early universe. The story was the front page news in the May 21, 1965 New York Times. Penzias and Wilson shared the 1978 Nobel Prize in Physics for their discovery of cosmic microwave background radiation. I find it absolutely mind-bending to think that all around us in every direction is the first light from the universe. It's everywhere. And if we have microwave eyes, we can actually see it. The uniformity of the cosmic background microwave radiation intrigued many scientists. This is because it's uniform in temperature to about 1 part in 100,000. The event that achieved this uniformity has to be a highly planned event and not a haphazard event. The uniformity of the radiation revealed that the properties of our galaxy, the Milky Way, are basically the same as those of extremely distant galaxies. It is as though you entered a marriage party to find out that all of them were wearing the same color as you. If just one or two of your friends were dressed in the same color, it might be explained away as a coincidence. But if the big group is dressed in the same color, you might think that the bride and bridegroom had coordinated the color in advance. At the Goddard Space Flight Center, astronomers began to develop a satellite that could measure variations in the background radiation and finally launched the Cosmic Background Explorer (COBE) in 1989. COBE could map the microwave background radiation and found that the temperature variation is just 1 part per 100,000. These tiny differences measured by Cope were particularly important because they pointed to the seeds of the modern day universe. In a news conference on April 3, 1992, Cope scientist Smoot announced that Cope had observed the oldest and the largest structures ever seen in the early universe, the huge ripples in the fabric of space-time left over from the creation period. And then he uttered this famous quote, "It is as though you are seeing God." Stephen Hawking called this finding the discovery of the century, if not all time. Despite its spectacular results, Cope could only present a crude map of the variations in the background radiation. So the Wilkinson Microwave Anisotropy Probe WMAP was launched in 2001 to look for anisotrophies or variations in the microwave background with a higher resolution. WMAP's latest results fully confirmed Cope's results. Charles Bennett, WMAP principal investigator, was amazed and he announced, "We have never before been able to understand the infant universe with such precision. It appears that the infant universe had that kind of growth spurt that would alarm any mom or dad." Along with mapping the embryo universe, WMAP also could pin down the age of the universe to 13.7 billion years. Cope and WMAP observations provided confirmations for the abundance of light elements like hydrogen, deuterium, helium, and lithium in the early universe, thus confirming that the universe was not eternal but started at a single point billions of years back. Just like how our universe came into existence out of nothing, light too came into existence out of absolute darkness. The act of light coming into existence was a process in time. When we analyze this event, we find that the event was not a haphazard event but a planned event. Scientists are amazed at this accuracy and planning. But what is the source of the planning behind the emergence of light? It's intriguing that the emergence of light out of darkness is the very first thing that happened in the universe, just as the very first chapter of the Bible says.
Then God said, "Let there be light," and there was light. And God saw the light, that it was good, and God divided the light from the darkness.
That's all for today. See you again in the next episode.